Welcome back to our channel. In this video, let us write the Python project to build a machine learning model to predict whether it will rain tomorrow or not. A machine learning process is a subset of artificial intelligence, and it begins by feeding the machine with lots of raw data. The machine is then trained on this data to predict hidden insights and patterns, which is used to build a machine learning model by using an algorithm in order to solve or predict the outcome. The data set that we are going to consider is a daily weather condition as observed in the weather station, and since it is a categorical data, clearly we can solve this as a classification problem, which is a supervised machine learning. So we will do this in steps. I have split this into 10 steps, not to bother because most of the steps are very easy. First step is to load the data set. Second step is remove not so significant variable from the data set. And the third step is to remove any null values from the data frame. This way we are pre-processing the data frame in step 2 and 3. The fourth step is to normalize or scale the data set to remove any biases to get an optimized predictable output. Step 5 is to analyze the data and identify the significant variable, which is usually done only by brainstorming. And step 6 is we have to put these important features, significant features, and form a data frame. And step 7 is data splicing, and step 8 is using the data spliced data we have to train the data set, and the step 9 is evaluate the model you on the test data set, and the last step is calculate the accuracy of our model that we have built. So just code along with me. It will be very easy as most of the steps are only one or two line with the built-in methods. First, let me import pandas and numpy packages. Coming to step 1, which is load the data set. This we will do using the method read CSV provided by the pandas. And here I am going to pass the path of my CSV file, which is file having the weather information. You can use your own CSV files and provide the path here. So this ensures the data set is loaded and it is available in the variable df. Now for our understanding, we will print at this stage to know the size of the data set by calling df.shape, and also let us try to print 0 to 5, that is 4 rows of the data set. We can see that size of the data frame is 16,743 rows and 16 features. 5 rows are printed and 16 features. Some of the columns that we can see is date.full, rain today, rain tomorrow, some wind speed, month. So there are totally 16 features available in this data set. Don't worry, you can use your own data sets, but the procedures and the steps shall remain same. Moving further, that is in step 2, we are going to do pre-processing on the data set. So remove not so significant variables. This is easily achieved because pandas provide us a method drop. So I'm going to drop some 8 features from the data set. From your data set, you can identify not so significant features and then pass here. It may be 8, 2, 3, 4, or as per the database, that data set that you have chosen. So the drop method, I'm going to drop this many columns. And now again, let us see what is the size of our data frame by calling df.shape. Because originally, if you remember, we have 16 features and I am dropping 8 columns like date, full, month, week of, year, city, code, location and state. So again, let us print the rows 0 to 5. As we know, 0 is included, 5 is excluded. So 0, 1, 2, 3, 4, 5 column, 5 rows will be printed. Now if we see, uh, we have the output printed after step 1, which has 16 features, and we also have the output printed after step 2, which says database has 8 features, because we have dropped 8 other non-significant variables. So moving further, step 3, we will check if there is any null value in the data frame. So this can be done with drop NA. When we use drop method, we are completely removing those features. Now drop NA will remove a row if any one value is null. So that's why I pass a parameter how equal to any. So drop NA is to remove a row with a null value, whereas drop method is to drop the columns as specified. There is not null value from the data frame that I have chosen. So we see same number of rows, that is 16,743 rows. But still, this is a good step to have the predictable significant variables optimized for it. Now I am also trying to replace no and yes with 0 and 1 respectively for rain today and rain tomorrow. And again, let us print the 5 rows and then compare the outputs with step 2 and step 3 for these two columns, that is rain today. We can see rain today and rain tomorrow has 0, whereas in step 2 our rain today and rain tomorrow were actually no. So step 2 and 3 has been used as a pre-processing for optimizing the features in the database. Now, actually, we have to proceed further to step 4, and I am removing the print statements that is used to show the intermediate results. But after removing print, you can very much see step 1, 2, 3 are just one method or one line of values. Step 4 is to normalize it. We do normalization to remove any biases while predicting the outcome. To do this, we will make use of min-max scalar function that is present in the Scikit-learn library. For that, we will import pre-processing, and also we will identify significant variables for which we will use skybest function present in the Scikit library. So for normalizing, as mentioned, we are going to use min-max scalar. As we know, min-max scalar will scale the values in the database between the range of 0 and 1. And fit method, by passing database, we are calculating the standard deviation and variance. Again, the data frame with scalar dot transform method. The transform method will calculate the scaled value based on the standard deviation and variance that we have calculated in the previous step using fit method. So now our data frame variable df has the scaled values, which is very good to use for predicting the outcome because the biases are removed by scaling them. And the next step is to analyze and identify the significant variables that will help us to predict the outcome. Before that, let us take the input and outputs. X being an input will take the values or the significant features are anything other than the column with rain tomorrow. That's why we assigned x equal to df, that is database of location, everything except column not equal to rain tomorrow, and rain tomorrow is our y, that is the output. So x and y are input and output respectively. We will use select k best method to select three significant variables which have high chi-squared value. So we are passing high chi to chi-squared statistic will be calculated by the method select k best, and the highest 3, that is k equal to 3, no, so only highest 3 chi-squared value will be taken. Now fit x, y value will select this high value features of the significant variables based on the chi-squared value that we have calculated using select k method. Now let us execute and see what are the three significant variables. As per my database, precipitation, temperature, minimum temperature and rain today. These are the three significant variables, but your significant variables could be based on the database that you have chosen. So don't worry if you get different results. You may also try changing the k values and then see it. The get support method in step 5 is to give the index value of the selector so that we could print the columns when we get the indexes. That's why we got 3 values, and now I'm going to build the data frame with these 3 significant features and the predictable variable. So our database DF data frame is now having precipitation, temperature minimum, rain today, which are achieved by taking as a significant variable, and rain tomorrow is the variable which we have to predict it. That's an output. But to simplify the computation, we will assign only one of these significant variables as an input. So I am taking x, that is input, as data dot precipitation, and y as rain tomorrow, which is the output. So this is just to simplify the computation. So we have completed 6 steps very easily, and the 7th step is data splicing. So data splicing we have to do on the data set, for which I have to download the packages provided by Scikit-learn. So we will be using logistic regression. Although name is logistic regression, it is a classification algorithm. So from Scikit-learn linear model, we will import logistic regression, and also from Scikit model selection, we have to import train test split. So data splicing, as it indicates, we have to split the data for training and testing. So x and y are input and output values respectively. So in input x, we have to split for train and test, and y output we have to again split for training and testing. The split ratio that we have chosen is 25% for test size. That means 75% of the data set will be used for training. Now we will call logistic regression method by passing random state equal to 0. So this we have done data splicing for testing and training on input and output variables. So coming to step 8, which is actually to build the model using the training data set. As we see, we are going to build the model based on the logistic regression. So call the fit method for logistic regression and pass the training data for input and output. I take yTrain.values.Ravel because previously yTrain was a series. Now it is a numpy array. That's why dot values will give the value in numpy array and dot Ravel will convert that array to n. Now step 7 is to test the data. So now we are not getting any significant output. So let us calculate the accuracy of this logistic regression. So let me import accuracy score from Scikit-learn metrics. It's very simple because there is a method called accuracy underscore score which gives us the confidence level on the test data versus data predictor. So we will print this score and then see how good is the accuracy on this model built using logistic regression method. So now I am executing it. I got error, no module Scikit-learn. Okay, there is a spelling mistakes. I have corrected it. The matrix which provides the accuracy score, we could see that 0.8965 is the accuracy, which is close to 90%. That's between 89 to 90%, which is a very good accuracy actually, considering the size of the database, which is more than 16K. So now walking through the code, we have imported pandas, numpy and scikit-learn methods. The first step is to load the data set using a read CSV method provided by the pandas and pass the path of our CSV file. Here I have taken weather project. You can try your own weather database that you take from the internet or any other practical problems for which you need a solutions. Then use the pre-processing to remove insignificant null values from the database before proceeding to scale down the database to remove any unbiases. We are doing min-max scalar and calculate the standard deviation and variations, and then do the scaling. At step 5, which is very important, we have to analyze and find the significant variable, which is most deciding factor, because in machine learning we have to manually feed the significant variables, but here we have used some methods like select k best using chi-square statistics. We take 3 high valued chi-square, and then at step 6 we build the database with this 3 significant feature along with our predictable output, that is rain tomorrow. X and Y are input and output respectively. X we are taking only one significant to reduce the computation time and use only data prediction. Y is our rain tomorrow. And the step 7 is to do the splicing for training and testing on both input and outputs, and we use logistic regressions. First we are training it, then predict it and calculate the accuracy score. Hope you like the video. Please subscribe if you have not already. Subscribe to our channel. Please share to anyone who needs this video.